This is 5.3 properties of logarithms. The last lesson was studying what a logarithm is and how to write it in exponential form and how to write exponential form into log form. This one is more like evaluating logarithms more specifically and then condensing it, learning certain properties. So let's first start off with the change of base formula. So the change of base is if I had a problem like these examples. So if I had log of base 2 of 5. Now some of us, I showed you the other day in class how you can change, like if I had to do this to on a graphing calculator, log of base 2. So I'm going to go to log base and just type in log 2 of 5. Okay, so that was easy enough. But what if you're using a calculator like a TI-83 or some other calculator that does not have that feature? It only has the log button. Well, one way to do it is using the change of base formula. So even if, by the way, even if you have a TI-84 like this, it may be quicker just to use the change of base formula instead of doing the math and scrolling, instead of typing in those things. It may just be easier to use the change of base formula. So here, this is literally the log of 5 divided by the log of 2. So if you literally just type in log 5 divided by log 2, and notice we got the exact same answer. So this can be evaluated log of 3 divided by log of 7. Log of 20 divided by log of 12. So again, students, it don't matter what calculator they have, they can simply evaluate any base if they know the change of base formula. All right, so log properties. You may want to pause the video and make sure you understand these properties. These are very essential properties for logarithms. It's going to help us solve a lot of word problems as well. So here we have the log of if we have a multiplication of two numbers being multiplied, that's the same thing as if I had log x plus log y. So again, even if I had log of 2 times 3, that's the same thing as log 2 plus the log 3. Okay, so it's the exact same thing. The next rule, number 2, is if I'm dividing them, so if I'm dividing them, that's the same thing as the subtracting of the individual logs. And here, if I have log x raised to the y power, that's the same thing as if you have y on the outside being multiplied by log of x. So let's look at a few problems. So if I ask you to expand this. Now, expand basically means I'm going to, kind of like if I expanded a certain problem, like whatever, just for instance, if I had this number right here, well, that's really taking 300 plus 40 plus 7. See, I expanded 347. And so that's literally, I'm writing 300 plus 40 plus 7. I expanded it, and it means the same thing as 347. So what I'm going to do is I'm going to expand this logarithm problem into different components of it. So here I have, notice this is multiplication. And remember, the multiplication rule is that literally means the addition of each of those. So that's literally log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Again, that first property says if I'm multiplying them together, it's the same as the addition of each log. Notice a couple things. One, the base of 4 was written on every one of them, so don't forget the base. And then I added each one of these, so 5, x cubed, and y. Now the thing is, am I done expanding? So it's kind of like simplifying a fraction, reducing a fraction. You have to keep reducing until it's reduced all the way. So you have to keep expanding until it can't be expanded anymore. Well, notice this guy right here has an exponent. And if we go back to the rules, the properties, so rule number 3 is if I have an exponent, it's the same as if I brought that out. So here, this one stays the same, log base 4 of 5. This is literally 3 times log base 4 of x, and then log base 4 of y. So the only thing that changed was this middle term, is I took the exponent and I brought it out front. So this right here is the expansion of that. They both mean the same thing. Now, look at it this way. To practice it, you need to know how to go backwards. So in other words, if I gave you this as the problem, you need to condense it to that. You need to know how to go from the expanded form to the condensed form, and then the condensed form to the expansion form. Let's try another one. So here I have ln, and notice I'm dividing this. Dividing means the same thing. If you go back to rule number 2, so I'm dividing, I'm taking this. I guess you don't really need the parentheses. And then subtract ln of 7. So you're taking the ln of both of those. I expanded it. The other thing that can be done, notice this right here is the same thing as 3x minus 5 to the 1/2 power, which the 1/2 could be written out front. So this right here is the expanded part of that problem. And again, make sure you know, if I gave you that problem, make sure you know how to condense it back to that problem. So now let's go backwards. I keep talking about condensing and expanding, so let's make sure we know how to condense it. So here's an expanded form, and I want to make sure I know how to condense it. So on this problem, I'm going to, first I see a number on the outside, so that's the same thing as log x to the 1/2 power. And the same thing here, I see a number on the outside, so that's the same thing as x plus 1 cubed. Okay. Then I see, well, actually I'm going to rewrite this one as log of the square root of x. And then I'm going to condense it. Remember, condense means I want one log, just one log, the word log written once. And then, again, a plus sign of these just basically means I'm going to multiply the square root of x times x plus 1 cubed. Okay, so this is a condensed version of the original problem. Same thing here. I'm going to take this exponent, write it up top, so ln of x plus 2 squared. And then subtraction of the natural logs is just the division, so we're going to condense it down to 1 ln, and so that's x plus 2 squared over x. That's the condensed version. Okay, that's the properties of logarithms.